My name is Annie Evaristus Chidebere, a physics teacher. This is an apparatus before you. It's under mechanics. So we have a meter rule. You all know the function. We have a spiral spring. We have a boss and clamp. We have wheel stand, free-toe stand, and also boss and clamp holding the meter rule. While this one holding the spiral spring. We have stopwatch. We have a 50-gram mass and 4 sets of 20-gram mass. Then, if you see this apparatus being set before you, is to determine Hooke's Law. That is determination of Hooke's Law. Now, Hooke's Law states that the change in extension, that means the change in this extension of this spiral spring of a elastic body is directly proportional to the load applied to it. That is this mass applied to it, provided that the elastic limit is not exceeded. The elastic limit means once it is going down, as you are adding your load, so far the elastic limit is not exceeded. That is the determination of what? Hooke's Law. So after knowing that, you might be asked to plot your graph of mass against this if there is no meter rule. But if there is a meter rule, you are going to measure the L0, that is the distance between your spiral spring to the ending part without the mass attached to it. That is to get your L0. After adding your mass, you will notice the spiral spring will increase, will go down. You will measure, that is your normal L. Getting your extension is E is equals to L minus your L0. That is under extension, which is the Hooke's Law. So either you'll be asked to plot a graph of your E against T squared, which is your stopwatch, or your mass against your T squared. So that is it. Then as you are adding your mass, your extension will be increasing to be going down. This is mass 70 after putting the 50, mass 90, another one 110 to be going down, and 130. In all these masses, it must undergo vertical oscillations. It depends on the kind of oscillation we will given to you, maybe 10 oscillation or 20 oscillations. So after performing that, you have to remove your masses in order not to weaken the spiral spring, because the more you add these masses and you leave it for so long, your spiral spring will get more weaker and weaker. So that is the brief explanation on this experiment called Hooke's Law, to determine the Hooke's Law, which is under mechanics experiment. Though we have a lot of experiments under this mechanics, a lot, both in SS1, SS2, and SS3. So, but I want to use this to explain some of these little of the experiment under this mechanics. Thank you for listening.